Welcome everyone to this afternoon session, Working with Data, session 1. My name is Teresa Gregory. I'll be hosting and my co-host is Robert Bush. There will be 2 presentations during this hour, which they'll be each 30 minutes long. Robert will go ahead and introduce those in a moment, but I wanted to get up a few housekeeping things first. Remember to use the chat if you want to speak to each other and other attendees. But if you have questions, to please put those in the question and answer, the Q&A box over there on the right-hand side, to ask any questions you want during the session. Those will be moderated by Robert, and he will give those questions to the presenters at the end of their talk every 30 minutes. If you have any other questions, you can put them in the chat, and we'll try to answer them as we can. But other than that, I will turn it over to Robert.
Thank you, Teresa, and thanks everybody for showing up this afternoon. We hope you have a wonderful time here at AGIC. Today's first presentation is titled ADOT, Navigating Roads to Data Visualization. Sage Donaldson and John Ehlen are our presenters today. I want to give you a little background information on both of them. Sage is a Geographic Information Systems Specialist and an HPMS Analyst for the Arizona Department of Transportation. She has a BS in Environmental Studies and Geography from the University of Arizona, and her responsibilities include producing and assisting in data visualization, coordinating with local agencies and other groups to gather data for reporting purposes and other transportation GIS analysis and mapping needs. And she's an active member in AGIC and the Arizona Women in GIS chapter. John is a GIS project manager for Gistic Research Incorporated. He has an MS in GIST and sits as a voting member on GIS standards development and groups through both the National Emergency Number Association and the AGIC 9/11 Committee. Additionally, John serves as an adjunct professor at Embry-Riddle Aeronautical University, where he teaches GIS, and he also manages and co-hosts the FME in Transportation Special Interest Group on LinkedIn. Please welcome Sage and John to today's presentation.
All right. Hi. Thank you, Robert. John, are you able to share your screen?
I am still trying. It was set host disabled participant screen sharing, so I'm just getting that up right now.
No worries.
You should be set now, John. There you go.
I got it. Here we go.
Sweet. All right. Well, yeah, thank you, Robert, for the introduction. My name is Sage Donaldson, as Robert said. I'm the HPMS coordinator for ADOT. And so to get right into our presentation today, the impetus of these dashboards that we've developed and data visualizations we've developed at ADOT here is through the importance of data management, So what is data management? Broadly, it's the collection, organization, and the protection and storing of an organization's data so it can be analyzed for different business decisions and business use cases across the board. But getting to that good data management is super necessary. So what's needed to perform good data management? Firstly is data prep, cleaning and transforming raw data into the right shape and format for analysis, including making any corrections or combinations of a data set. Organizing your ETLs, so taking your data from one system, transforming it and loading it into our data warehouse in this case, but whatever data warehouse that may be. The data warehouse itself, having a place to consolidate various data sources, contend with different data types, and provide a clear route to doing that data analysis. Having good data governance. So this is defining standards, processes, and policies to maintain your data security and integrity across the board. And lastly is having really useful metadata. So creating that standard work and processes and explanations of these data items that are oftentimes complex and giving yourself a good tool to hand off to other users. So why data management is so important? Firstly, it's imperative to effective data analysis. And second, it allows easy access and trusted data for other business units to do queries and use your data in different ways. So ADOT's used data management in a variety of ways, but most recently has put QC into dashboards in order to allow for best practices. However, before the development of these dashboards, data was QC'd manually. Bugs proceeded in our database really easily, and there was not an automated process to catch and find these instances of data errors, whether input or other computerized. So now we have these QC dashboards in place, and this has allowed us to have managers in real time be able to review data errors and data bugs. Automated processes have been in place to find and catch data errors and data bugs. And it's also allowed us to prioritize data issues to tackle the higher order items, as well as categorize data errors and data issues to best know what to focus on. So now even externally, being able to put out these dashboards allows for external data management. This allows users to make informed decisions across a variety of data sources and systems. It allows for easy data distribution of metrics out to the public. And they're visually appealing, interactive, and data-centric places to find standard information and standard definitions. So on the back end, though, we've made a lot of metadata enhancements, but firstly, metadata is typically used to better describe items that are not included in whatever data source you're looking at. The purpose is to summarize the basic information needed to understand the data set itself. And it's really important to finding and working with a data set in order to understand and comprehend how to use it and where you can go with it. So metadata, can be kept at a high level or can be really comprehensive. It can be process oriented and very specific to a data set. Traditionally, it's formatted in some kind of list or document, and it's typically not interactive and not applicable to a broad spectrum of topics. So it can look like this in some kind of flowchart diagram. It oftentimes looks like this. Or in our case, it looks like this. So ADOT has enhanced metadata with the use of story maps. These allow for an easy distribution and can be best connected to the data sources in the dashboards. They can be kept at a high level and very data-centric and also visually appealing. And most importantly, they're easy to embed within the dashboards to allow for the best use of the data and the best understanding of the data for our customers. So going from something very list-like and something very specific to a data-centric, so getting into the data itself and understandable use. So there's also other uses of story maps, though, that we've used within our dashboards and to distribute publicly. So John, next slide, yeah, thank you. So we've talked about metadata quite a bit, but displaying the information at a high level to allow for more accessibility and easy to understand data outside of any specific industry. But you can also use them for analytical purposes, describing an analysis, a project, an outcome, and allows for the readers to understand the analysis that took place while being able to be in the data itself. Trainings are another really good use. Doing trainings inside story maps allows for a more interactive format, and it also allows for really good graphics and information to be used. Coordination is another really, really awesome way to use story maps. And creating coordinative apps to best describe what our needs are from the stakeholders, and embedding our data and input systems allows for greater coordination across the board. So that's embedding applications like Survey 123 or maps, and really describing your use cases and need for that coordination. Next is tutorials. This is the ability to interact with the data live and hands-on. And it allows the story maps to be really easily distributed to a variety of users. The example here is our traffic data input system. This story map is distributed throughout the state as a way to inform local agencies on how to share their traffic data with us. And lastly are our visualizations. This is kind of the punchline here for this, but the story maps are really easily embedded into dashboards where this allows the users to go and read through these really complex data items or read through their use cases to know what they can really get out of the dashboards. This is both internal and external, distributed across the board. And with that, I'm going to hand it off to John.
Awesome. Thank you so much for that background, Sage. I think you gave us a good context for why we use these dashboards and embed metadata into them. So moving on, in terms of the dashboards, one of the things that was the impetus for this dashboard was actually the coronavirus pandemic. And this was due to the fact that the MPD team at ADOT was unable to access their internal dashboards and metrics from outside the ADOT firewall. So at that time, most of the dashboards were built using Tableau. And while Tableau is an incredibly powerful data visualization tool, it suffered the critical flaw of being limited to the ADOT intranet and was unavailable for use outside ADOT's firewall. This presented not only a huge problem for ADOT managers and staff who were forced to work remote, but at the same time presented the team at Gistic with an exciting opportunity to investigate the potential substitutes to Tableau. So we limited our analysis to technologies that were both accessible outside the ADOT intranet and already in use by ADOT. These criteria meant that we could begin testing and development with no budget considerations and no delays due to software acquisition. Within this scope, we identified 3 platforms that we had at our disposal: Fme, ArcGIS Online, and Google Data Studio. Ultimately, we determined that the best approach would be to integrate all 3 technologies, allowing us to take advantage of where each platform truly shines: orchestrating data translation and migration using Fme, spatially displaying assets in ArcGIS Online, and the powerful tabular capabilities of Google Data Studio. The blending of these technologies was instrumental to the success of this project. Today, we're going to be looking at one dashboard in particular that I was tasked with recreating, and this is the ADOT Structure Summary Dashboard that was designed to provide summary statistics regarding the national bridge inventory metrics that are submitted to the Federal Highway Administration. The dashboard consisted of 5 separate tabs, each of which we needed to replicate. Here we can see the landing page tab, which offered a short data disclaimer and an introduction regarding the dashboard contents. Next, we have the Performance Summary tab, which also offers a historical summary of the DEC rating for structures throughout the state. This page has a few metrics used to filter the data, including whether or not the structure is on the national highway system and whether the structure is owned by ADOT or a different agency. Next, we have the annual Nbi tab, which gives a summary of structures belonging to the national bridge inventory. This report also contains the ability to filter based on various metrics, including whether the structure is a bridge or a culvert, and whether or not the structure resides in the national highway system. The map tab of the Tableau dashboard offered a simple graphical representation of the structures along with many different metrics to filter the data. However, the Tableau map is not the most performant. The More Information tab included a series of links to metadata pages and story maps to obtain reference material. And these are the story maps and reference material that Sage previously talked about and showed some of, and we'll show a little bit more at the end of the presentation. Some additional criteria that were in play that we need to mention are the recreated dashboards must also be presented in a single location, just like the Tableau dashboard, despite them being comprised from 2 different technologies by 2 different providers. And secondly, the landing or splash page needed to be maintained so we can have a data disclaimer. So now that we know what our goal is, recreating a Tableau dashboard using ArcGIS and Google, how do we accomplish that? Here we can see tab 1 of the redesigned dashboard, and we're going to kind of look at the finished product and then bounce back a little bit going into this. So as I mentioned before, it was a requirement to have a data disclaimer page, and to accomplish this, our entire ArcGIS Online dashboard is nested inside of an ArcGIS Online experience builder as an embedded content object, allowing us to have a pop-up on the disclaimer page. So clicking do not show again and OK allows us to get rid of that pop-up, and then we can navigate into the dashboard. So the experience builder itself that the dashboard is nested into a Google Data Studio report that also has embedded content. So we kind of have this multi-layer nesting effect going on. Next, we have the recreated Performance Summary tab. While it slightly differs from the Tableau version, it does display the same information with a more modern look and feel. Again, we have the ability to filter by jurisdiction, highway system designation, structure ratings, etc. And then next we have our annual Nbi tab. This tab displays metrics by both structure count and by total deck area of the structures. And I think it's important to note here that when we visualize data, it's critical to widen your scope and really look at the entire picture. And this is why we visualize data both by deck area and by the structure count. Because if you imagine you had a system with only 10 bridges and 9 of those bridges are 15 feet long and they're in perfect condition, you would have 135 feet of good pavement. And if you imagine your 10th bridge is 500 feet long and it has poor pavement, when we display metrics by structure count, you would get a false sense of confidence regarding your asset condition because 9 out of 10 structures were good, when in reality, 78% of the pavement was poor. So this is why we try and display dashboards from both sides of the story. And finally, we have the more information or the metadata tab. And this tab contains an ArcGIS Online experience builder nested as embedded content in the Google Data Studio report. And the experience builder itself is a series of nested content objects that are all the story maps that Sage over at ADOT maintains. And not only does the report include all of these metadata dashboards, from sort of certified public miles to HPMS to functional classification, but it also has historical reports baked into this. And so within the dashboard, the users don't actually have to leave the dashboard to look at historical reports from certain years. So right now we're looking at extent and travel during the statewide for 2020. Now we're looking at extent and travel solely on the NHS. Now we have the full extent lane mile ratings. And the nice thing about this is it allows you to compare reports year by year really easily. So right now we're looking at 2020, but we can also look at 2019, 2018, or 2017 to kind of get a sense of how this data has evolved over time and what the previous reports look like. Additionally, we also have a multi-year report, which is an aggregation of all of the years combined at a summary level. So this really provides the users not only the ability to look at the data and drill down, but also look up the ancillary information and learn more about what is trying to be displayed in this dashboard. So now that you've seen the original and the finished product, let's take a look at the back end of this and how it was accomplished. There are really 2 critical factors that allowed us to accomplish this lofty goal. The first key component to the success of this was the ability for Fme to integrate and communicate with various systems, including SQL, ArcGIS Online, Google Drive, Google Sheets, Excel files, and file geodatabases. Pretty much all of those and possibly more formats are used in this process. The Fme component process at its simplest involves reading edited records from an ArcSDE database on a defined schedule, pushing those edited records through a QC process, and then populating the QC tables with fresh data. The second critical component to the success of this project was that both ArcGIS Online and Google Data Studio allow us to embed content, allowing us to really seamlessly merge technologies into one location, which was previously a lot harder to do. So all of the dashboards are powered by different Fme processes, and most of the Fme processes we use at ADOT use custom transformers that we've developed at Gistic Research. These Fme processes read directly from an ArcGIS Roads and Highways SQL database, and they perform many different quality control evaluations. While it's not shown here, the QC files are logged in an error table for review by the GIS staff. Next, the data is split into separate paths depending on whether it needs to be visualized spatially or in tabular format. On the tabular side of things, we write the data to different Google Sheets stored in ADOT's Google Drive account, and these sheets are tied directly to the Google Data Studio reports as data sources, and they are used to power the various widgets and filters. This setup allows us to bypass the cell limitation of Google Sheets and the fact that we can truncate and repopulate the Google Sheets and update them as much as we need to kind of have this as an on-the-fly picture rather than looking at everything over the entire system. On the spatial side of things, we have a fairly unique setup due to some budgetary constraints. We were not allowed to use any ArcGIS Online credits for storage or analysis purposes, meaning we had to find a place to store our data free of charge while also keeping it accessible. This is no easy task. Luckily, the Arizona State Land Department has created AZGeo, and since ADOT is a government agency, we were able to utilize ADOT's AZGeo account to load and host data as hosted feature services. These hosted feature services loaded to AZGeo are private to the ADOT user, and they are editable, so we can update these as we need to. From there, we created public-facing table views of those hosted feature services to allow consumption from different organizations. Next, we created the map and dashboard in the ADOT ArcGIS Online account using the public-facing views coming from AZGeo. Finally, these dashboards were embedded into an experience builder for the sole purpose of obtaining that splash page. Within the ArcGIS Online side of things, we also have a series of story maps hosted on ArcGIS Online account, on ADOT's ArcGIS Online account, that are nested into one experience builder interface to aggregate them into one location for easy access. And that experience builder is what's nested in the Google Data Studio report as the Metadata tab. Finally, all these items are combined together into one location to make the Google Data Studio dashboard. The final elements that comprise the dashboard are shown here in the black dashed outline. Now, I want to give a 1-minute shameless plug to our custom transformers, and only because they are publicly available for free for everyone to use. So I won't go into depth talking about what they do or where we use them, but I just would like to say that they are all available for free on the Fme Hub at that URL there, and you can download them and QC your own data and play with these outputs at your leisure. So some of the most common ones we use are the Geocoder, where we take non-spatial LRS events and convert them to spatial features, or the reverse of that, where we have spatial features, but we want to convert them to LRS measures. We would use the reverse geocoder. The event merger can merge adjacent and connected LRS events if they share the same attributes. The route QCer and event QCer do quality control on LRS events and LRS networks respectively, looking for gaps, overlaps, temporal discrepancies, all of that kind of stuff. And the event to straight line, the event to SL transformer generates planimetric straight line geometry to allow for intersection identification of measure ranges. And that includes not only the LRS side of things, looking at LRS measures, but this can be kind of extracted and applied to address ranges on road center lines. So you can actually build planimetric geometry with this transformer and identify overlapping road center line ranges as well. So now back to the dashboard. Now that we've looked at the process kind of behind the scenes, let's take a look at the structure of the dashboard kind of from the other side of things, including its nested components. So as we mentioned, the structures dashboard is comprised of 4 key components. The first one being the GIS NHS structures dashboard, which is hosted on ArcGIS Online. This report is a summary of the details in the dashboard and provides current historical rollout metrics for the state. Sorry, I lied. Now, this tab is the structure summary dashboard, and it is just ratings and reports on the web map in widget format, which we kind of showed. And this is where we use ArcGIS Online spatial capabilities in place of Google Data Studio or Tableau. Our next tab, the performance summary tab, is the report summary and the details that provide current and historical rollout metrics for structures across the state. And you can see that this tab here is directly fed by a table inside of our Google Drive. Next, we have our annual Nbi tab, which is just like the performance summary tab, is a Google Data Studio product and lives in Google Data Studio. So all of that in the blue there is coming from Google Data Studio. And then finally, we have our ArcGIS Online Experience Builder. And here you can kind of see the nested contents of the different story map dashboards we have. So this diagram is kept internally for reference, and each of these underlined words provides a link to the item in question. And it's really important to keep these diagrams and visualizations internally because it helps us keep track of the complex structure of this process. It's really hard to remember what comes from what and what's embedded into what. So having sort of a flow chart of how things get embedded allows us to track back and make edits in the appropriate places. So that's all I have in terms of that. And now we just have some kind of important takeaways that Sage and I learned here going along the way. And I'll let Sage take a couple of these.
Sure. So one of the important takeaways from these dashboard developments internally and externally is that they enhance data-driven decision makings for users and customers, whether that be us internally or sending them to local public agencies across the state. Dashboards and metadata allow information to be more acceptable to a wider range of users. So giving that standard definition and those standard processes to each data item really allows users to benefit from this wide range of data. Applications give complex data concepts standard definitions on different subjects, and using those applications to their best advantage really allows us to better our data management across the board. John.
And in today's modern world, the integration between various systems gets easier and easier every year. And this is why it's so important for all of us to read our update and change logs and all these boring documentations that GIS companies routinely email us that we either hit spam or just instantly delete. A lot of these changes are listed in the change logs, and you can, by reading these, you can know what you can do in the next year or the next 2 years in terms of integrating systems and seeing how the technology is changing. It's really hard to imagine a setup like this being possible 5 or 10 years ago, being able to really embed so much web-based content and really nest that inside of each other recursively. And the final takeaway is really that there's many different data visualization platforms that exist. However, they all do a certain thing better than others. And in this case, we learned that ArcGIS obviously excels at spatial visualizations, but it's very, very poor, and its offerings are exceptionally paltry when you compare that to Google Data Studio or Tableau when we talk about non-spatial visualizations. And with that, I believe Sage and I are done.
Thank you so much.
Thank you, everyone.
Thank you, Sage and John. We have a few questions for you. We still got a few minutes left. Early on, we had a question saying, so you linked story maps to dashboard to metadata. And then they have in parentheses for ease of, quote, finding data.
Yes, yeah, we did. And so I guess the punchline there is all within the same interface. We've been able to link that information. So I think John's pulling that up here. Yeah, so you can see our ArcGIS Online dashboards, the Google Data Studio dashboards, and also the metadata in the form of story maps. So all the information is in one place. You're not having to navigate to different areas.
Okay.
Yeah.
Go ahead, John.
I was going to say, Sage, you said that exactly correctly. I think the idea is that, story maps are really powerful, but ArcGIS Online kind of is not that great to search through it and look for content. And so by being able to create a metadata dashboard that has all of the dashboards relating to another dashboard in question in one spot, the users never have to leave this dashboard to figure out what public miles are, or to figure out the difference between our laned and maintained miles, or to know what the bridge inventory is. So kind of having everything nested into one spot allows them, if they have questions relating to these tabs here, they can answer those questions nearly instantaneously.
All righty. Thank you, John. We've got 2 more questions, hopefully have time for. This one you might have answered to some extent, but they're wanting to know, is your dashboard dynamic or static? How often is it updated? And is it data just from ADOT or many other inputs?
So these dashboards are still a work in progress, and I hesitate to say that they are 100% done. In terms of this dashboard, it's a structure summary dashboard designed to be a roll-up of previous year's data. So this dashboard would be updated once a yearly. And Sage, correct me if I'm wrong here.
Yeah. So I think that's kind of specific to our data as well. So a lot of the data that we maintain and collect is done for the HPMS federal report, which is something we submit annually. So by nature of our data, it's really an annual dashboard, a lot of these. So I hope that answers the question well enough. I can't remember what else was in there.
And in terms of that, we do have other dashboards like this one, which are meant to be a more rolling table that gets updated as needed. So this can be updated daily, weekly, monthly, really whatever the case is here.
Okay. The last question, we're almost out of time, but a quick answer should do, is when you create a custom FME transformer, then there is an upgrade to FME. Or when there's an upgrade to FME, will you be supporting that?
On the FME hub, it says which version of FME the transformers are built with. And it's always best practice to run that transformer with the version that's intended, because you can download historical versions for FME. But short answer, yes, we try and update them as we can. The majority of updates that come through to FME don't affect most of the transformers we use, as most of the updates are just dialog options changing.
All righty. Well, thanks, John. That ends our first half hour. I want to appreciate both Sage and John for giving a wonderful presentation. It was very insightful and kind of energetic. And I work with Sage, and great lady to work with. And I did not realize that you have that much stuff going on, Sage, with your data. And I work alongside you, so it's quite a surprise. With that, we're going to go to our next set of speakers. Let me get back there so I can introduce them properly. Give me just a second here. Our next session is titled ADOT Silo Connection Case Study from the Performance Controlled System, PeCos, as it's known, to GIS Boundaries. Our two speakers are Shaun Perfect and Karol Francis. Shaun is a senior geospatial analyst with the Arizona Department of Transportation. He's been a GIS professional for over 7 years, with a majority of that time within transportation GIS. He has a bachelor's degree in geography and urban planning with a certificate in GIS from Arizona State University. Shaun is currently maintaining ADOT's linear referencing system, or LRS, as well as coordinating with other groups to integrate non-GIS data into roads and highways. He has a strong history of GIS roadway characteristics, data analysis, and editing. Karol is a senior GIS analyst herself with Gistic Research. At Gistic, Karol works on projects related to analyzing and visualizing transportation data. Karol has created numerous Tableau and Esri dashboards and developed Fme processes that generate highway log products and a process that creates polygonal boundaries from non-spatial event data. Karol has a master's degree of science in GIS from the University of Arizona. Please help me welcome both Shaun and Karol to their presentation today.
Thank you, Robert. As Bob said, my name is Shaun, and I work closely with Karol on this project specifically. Karol, do you?
Yeah. Hi, everybody. Robert, thanks for introducing us. And I developed the process that we'll be talking about today.
So just getting into it, basically we'll be talking about how we took our PeCos system, which is managed by the maintenance group here at ADOT, and converted them into GIS boundaries. So some objectives with this project, we wanted to automate the translation of the non-spatial PeCos maintenance and engineering boundary definitions into a GIS layer, which we definitely support through our roads and highways integration. And within that, we wanted to support some data visualization for dashboarding and mapping, which Sage and John just went through. One of the more important things in this is we wanted to connect the correct data silos, in that Sage had mentioned in the past presentation that we deal a lot with data governance, and we want to make sure that we are getting the data from the direct source, and that we're not taking a copy of anything or anything like that, and we want the main data. In doing this, we have developed some quality control, some QC analysis that we use to relate back to maintenance and also on our side. Some PeCos history. I know you're looking at the word PeCos and I'm wondering if a kindergarten wrote that. But no, it makes sense. It stands for the Performance Controlled System. Has been used by ADOT for 40 years and has helped maintenance managers develop and carry out maintenance programs with planning, organizing, and controlling maintenance work. The main thing we want to say out of this is PeCos only contains tabular data. It isn't GIS enabled, and that is the main basis of why we wanted to do this project, to get it in the GIS so that we can use it within mapping and relate it to our other data. So with the maintenance crew, their specific names, we call it TSMO, it's Transportation Systems Management and Operations. Again, they deal with just the tabular data, and they use that data to send out their crews onto the field. Basically, that tabular data includes location information such as mileposts, routing, and anything else specific to the maintenance crews. So the correlation with these tabular maintenance records and GIS is that we host these layers within our roads and highways. As I said before, the roads and highways includes multiple layers of ADOT information, including pavement, traffic, functional classification, a lot of those ideas that Sage and John went through with their story maps. So we have all this data in the same roads and highways database, so we can integrate and overlay those data sources together, producing maps and dashboards for upper management. So we're talking about 3 of these layers. 2 of them are polygon boundary, the maintenance unit polygon, which shouldn't be confused with the engineering district. Now, the engineering district is broken up to 5 districts throughout the whole state, and the maintenance districts are within each one of those different districts. The MMS, Maintenance Management System, is a linear routing event based totally upon the PeCos tabular data. It actually fits right onto our roadway network, also called ADOT, and it allows us to overlay all the different events within roads and highways onto this linear routing event with maintenance. So basically, what we did before was we took a boundary change that was given to us by an email that upper management sent, who was ever in charge of the maintenance districts at the time and the boundaries. They gave us a milepost, and basically from point A to point B where it changed based upon the route and milepost information. And so we took that and we manually went into the roads and highways database and changed it. Now, on occasion, there were more than a few, and it was kind of a tedious task and time consuming, to say the least. So basically, we wanted to think above and beyond how we can get rid of this manual process and build it into more an automated process. So some of the benefits to ADOT included in this automated process, it gives ADOT's GIS data up-to-date validation. The automation, like I said, saves time and eliminated manual efforts. It reduces future errors and assists in collaboration efforts between ADOT groups. In this instance, MPD GIS, which is us, and maintenance. In other examples, one of the big pushes that we're doing now is teaming up with different groups within ADOT and some of different state organizations, and collaborating if they have tabular data to integrate that into GIS if it makes sense. Say, for instance, if they have any location data whatsoever, we want to bring that into ADOT in our GIS and be able to overlay that with a lot of other events. Giving, answering any questions, for instance, like pavement, we're teaming up with them to be able to maybe take these boundaries, these district boundaries and engineering boundaries, and provide some output. Say there's so many miles of good pavement within the Southwest District. And so we can put those up on the dashboards like John and Sage were referring to. It helps identify errors within PeCos boundary definitions. So a big thing that we got out of this was as we were going through the data and doing these automated processes, we found some errors within PeCos that we could fix, and we relate that back to the maintenance crews and the maintenance group. As well as it found errors on our side as well that we could fix up. So it was a win-win situation for all of us. And now I'll turn it over to Karol because she's the brains of this whole project. And so take it away, Karol.
Thank you, Shaun. So in the early days of this project, I thought it all seemed completely bonkers. How in the world was I supposed to create polygons from a non-spatial CSV? I felt like I was being asked to convert lead into gold. So I spent quite a bit of time researching. First, I needed to understand what the PeCos data represented. You're all familiar with milepost signs that you see when driving down the freeway. Well, the PeCos data table is basically a record of which roads each crew maintains, where the statewide road network is broken down into milepost ranges on each highway. Once I was able to relate this table to what I see when I drive down the freeway, I use standard geocoding tools created by Gistic and ADOT to convert the milepost ranges in the table to spatial geometry. Geocoding route segments is very similar to geocoding addresses, except we're assigning spatial location to bits of roadway instead of buildings. Well, now I had lines. How in the world was I supposed to draw polygons around these lines? Buffers, the obvious choice, just made a big mess. So I took the next obvious step and asked the hive mind on social media. This was actually a stroke of brilliance. Somebody suggested Thiessen polygons, which was critical to solving this problem. I built this process in Fme. If you're not familiar with Fme, it's a software package that's similar to Esri's data interoperability extension. And before I dive into the meat of this process, I'd like to talk about my favorite Fme transformer, the Voronoi diagrammer. My apologies to Mr. Voronoi for mispronouncing his name. I have looked it up on YouTube and I'm trying. I'm really trying to say it correctly. Voronoi diagrams are a type of Thiessen polygon. The Voronoi transformer is really cool. If you have a point data set, it draws polygons around each individual point. Every location within each polygon is closer to the point contained within that polygon than any other point in the workspace. This transformer is what allows us to draw polygon boundaries around our events. A screenshot of the non-spatial PeCos table is on the left. This table refers to routes and milepost ranges that are maintained by specific road crews. The beginning and ending columns in this table refer to the beginning and ending mileposts on a route that are maintained by a specific maintenance unit. The desired linear and polygonal output is on the right, which is a spatial representation of the same linearly referenced events. This flowchart summarizes the Fme polygonization process. There are two data inputs for this process, the route data set from the Roads and Highways database and the non-spatial maintenance event table from the PeCos database. We first geocode the non-spatial maintenance event table to obtain event geometry. Once we have linear geometry, we split the lines into points because the Voronoi diagrammer requires point input. Then finally, the Voronoi diagrammer generates polygons around the points. I would also like to point out again that at many steps of this process, we log data bugs, which are automatically emailed to the appropriate recipient in Excel spreadsheets. Now let's take a look at the data as it goes through the Fme process. These three screenshots were taken from critical intermediate outputs within the Fme process. Each screenshot illustrates the same intersection, where I-10 intersects State Route 202 South Mountain on the Phoenix-Chandler border in Maricopa County. The screenshot on the left shows the linear output of the geocoder. The center screenshot shows the points point output of the chopper, which is a transformer we use to extract the vertices on the lines, thus converting the lines to points. We then feed these points into the Voronoi diagrammer, which generates polygons around each point. These polygons look pretty crazy, but when we dissolve and aggregate these spiderweb looking polygons on maintenance units and their parent engineering districts, we get beautiful polygonal boundaries. As Shaun mentioned, this is an automated process that has removed many human factors from the connection between the PeCos and the roads and highways data silos. Furthermore, the Fme output table is temporal and retains a history of previous linear events and polygons. This is significant because the PeCos database is not temporal. Now, the MPD team at ADOT has a spatial and temporal history of maintenance boundaries to accompany the spatiotemporal roads and highways database. Now let's take a look at the process output. First, we see the spatial linear output of the process. Next, we see the polygonal maintenance unit output. The Voronoi process drew these polygons around the lines. Finally, we see the engineering district output, which is an aggregation of their child maintenance units. As we have mentioned several times previously, this process also has many data validation and QC steps baked in. On the next few slides, I will show examples of data bugs that we have found using the polygonization process. As I examined the process output, I found something that I thought was really interesting. There were a lot of little bugs in the non-spatial PeCos table that may have existed for years. However, since the PeCos table is not temporal, we really don't know the time extent of these data bugs. It's pretty hard for humans to digest tabular data, and the road crews didn't realize the table didn't quite match what they were doing out in the field. When we drew polygons around the non-spatial events, we found anomalies like this one in engineering district polygon output. In this instance, there was a small area of the state that was attributed to the central district, yet far away from the main body of the central district. This visual output allowed us to find that a road segment within the outlying central polygon was incorrectly assigned. This has since been fixed, and I added a QC check in Fme that identifies these tiny disconnected polygons. This is a similar issue to the previous slide, but this represents a new bug that recently appeared in the source data. In the maintenance unit polygons, there is a tiny area of roadway that is attributed to the Selectman maintenance unit in the PeCos database that is far away from the main body of the Selectman maintenance unit polygon. This exception is currently in review by the ADOT team. This jagged boundary between maintenance units was caused by a discrepancy in the PeCos database that indicated a small section of frontage road on Interstate 8 was being maintained by a different maintenance unit than the corresponding mainline roadway. When the Voronoi diagrammer drew polygons around these areas, it resulted in a jagged boundary. On the ground, the frontage road and the mainline in this area are maintained by the same maintenance unit. The PeCos database has been updated to reflect this reality, and the polygonal boundary output is no longer jagged. In conclusion, ADOT has historically used the non-spatial PeCos database to track which roads are maintained by which maintenance units. However, this database is not part of the spatiotemporal roads and highways database and has been